Greetings, thanks, man. We're going to do another method for solving systems of linear equations, this time actually using what's called the linear elimination method. So far, we have done substitution. I'm going to suggest one other method for solution here. We're going to have negative 2x plus 3y equal to 4, and positive 2x minus y equal to negative 8. Now, the key here on these problems, it has to do with when we have matching coefficients, or at least if the absolute value of our coefficients match. Here is the key here. When we have negative 2x and positive 2x matching, this makes a very quick and clean solution. You can just combine these two equations, okay? So you just take the sum of these things. So negative 2x plus 2x winds up being just 0, or we don't have to really write anything. When we add 3y and negative y, the result is going to be 2y. And we're going to add together 4 and negative 8, and that's going to give us negative 4. Now look at what we have here. It's a quick one-step solution where we're going to get that y is equal to negative 2. And that's our first of our solutions. All we have to do from there is we can reinsert this into either here, or we can reinsert it into here, to the top or the bottom equation. Of course, we would insert it to the x, we're going to insert it into the y. I'm just for the sake of less calculation, it's going to get the same answer either way. I'm going to insert into where that is y. So I'm going to have 2x minus, and then I'm going to put in negative 2 for y, and that's equal to negative 8. Again, I'm going to strongly suggest that when you substitute, that you're going to put something in parentheses. All right, it's going to create for the best result for you there. So we have now 2x minus 2, or 2x plus 2 equal to negative 8, and now we're going to solve. Minus 2, it's going to cancel. Well, 2x is equal to negative 10, divided by 2, Our 2's are going to factor out, and x is going to be equal to negative 5. So now we have our solution. It is going to be negative 5 comma negative 2. Remember, we have to leave this as a coordinate to be most complete. All right, let's try one more of those. Similar method. Doesn't always have to be x that gets eliminated. In just this case, it's going to be, again, watch. We're going to have 3x plus 2y is equal to 7. And then we have negative 3x plus 4y is equal to 5. Now, we're looking at these two equations in two variables. What we're trying to find is where do we have the absolute value of the coefficients match? And obviously, it's going to be here with the x's. That's great. When we have that, we're just going to combine. The result is going to be eliminating. It will eliminate what we have there for x, okay? So it's going to be 0, it's going to be 6y, and then 7 plus 5 is going to be 12. Y here, when we solve, is going to be 2. That's a quick solution. Take this guy, we can put it into either one. I'm going to put it into the top equation, and because that's going to be quicker for me. 3x plus 2, and then of course our y is a 2 as well when we substitute. And we're not substituting anything with a variable, it's actually just going to be an integer value, which is going to be much faster, I think, for us to calculate. 3x plus 2 times 2, which is 4, is equal to 7. Keep going. Subtract 4 from both sides. That cancels. 3x is going to be equal to 3. So x is going to be equal to 1. We have to write this as a coordinate. So this is 1, 2. Now, here's where it changes up a little bit. I'm going to do one more example here. Where we're going to eliminate the x's. And again, it doesn't have to be the x's. We're going to do some instances where we eliminate y. But I want you guys to see something here. Sometimes we don't have the luxury of looking at this thing and we have matching coefficients. I want to actually deal with this right here. I'm going to keep canceling the x. Now, I could just cancel the y's, but I want to show you guys something. When you do this, you can put parentheses around here and subtract, okay? Parentheses around these two and subtract, because this is what this is going to do for us. We're going to have 3x minus 3x, which is 0, but look at this. We're going to have a minus here, right? So we have 2y minus 2y, right? And that's going to give us a 4y. So we can add or subtract. We've just been adding so far because when we've combined or added, there's been an elimination because there's the coefficients have been opposites. In this case, the coefficients 3 and 3 for in front of x are the same. So it's okay. We can just subtract those away. We have 4 minus 4, and that winds up being 8. Okay? Where now y is 2. It's a quick solution. And I can plug it into either one. I'll plug it into the bottom one. Why not? So we have 3x minus 2 times 2 is equal to negative 4. Okay? 3x minus 4 is equal to negative 4. I'm going to add 4 to both sides. Okay, and this is going to be one of those issues that sometimes confuses us. Negative 4 plus 4 is 0. And then when we divide by 3, remember, when you divide 0 by anything, the answer is 0. It's when you divide by 0 that it's undefined, but here we're all set. So this guy is going to be, as a coordinate, 0, comma, positive 2. And that's our answer. All right. Doesn't stay so quick and clean, gentlemen. Gets a little bit more difficult sometimes. Like, for example, some of you guys might be wondering, hey, well, what happens if my coefficients don't match? Can I use the same method? And the answer is yes. Yes, you can. Now, our coefficients don't match in either case, next to the x or next to the y, but I'm going to make a match. I'm going to look at this guy right here. If I were to multiply this entire equation by 2, then I'm going to match, okay? Because if I multiply 2 times 3x, it's going to give me a 6x. Now I have matching coefficients for the x, and we're still eliminating x. It doesn't matter which one we eliminate first. We're going to eliminate y, okay? Keep going. 2 times 2y is going to be 4y. Remember, the biggest mistake that's made here is not distributing to every single one of these terms, including the term on the right. So 2 times negative 2 is negative 4. This is the biggest mistake that people make on these problems. Okay? So now I can combine. Negative 6x and x is 0. Negative 5y and 4y is negative y. And 2 and negative 4 is negative 2. So y is going to be equal to positive 2. I'm going to take this y, and I can plug it in wherever I want. I can plug it into any one of those 3 equations. It's going to wind up giving me the same thing. I'm going to go back and put it into the very first one, the original. Okay? So I'm going to write over here 3x plus 2 times our y is now 2 is equal to negative 2. Keep going. 3x plus 4 is negative 2 minus 4 minus 4. 3x is equal to negative 2 minus 4 is negative 6. And divide by 3 on both sides, and my x is going to be equal to negative 2. As a coordinate, it's negative 2, comma 2. All right. Last one of these. Now, this next thing, I would actually probably utilize substitution, frankly. But let's just see, because we can use either method. It doesn't really matter. It's important that we're able to do both. And as always, you can use one method to check the other. So nothing matches. Now, typically, you would just solve for one of these two, right? And then you're going to substitute in, solve for one of these two variables, x or y. Or we could do something a little bit different. I'm going to multiply these guys by, this top one, by 4. All right. The reason I'm going to do that is so that way I have matching x's. Actually, you know what? Let's do it the other way, because we've been setting up to eliminate x. Let's set up to eliminate y. So let's multiply this guy by 4 instead. X times 4x is 16x plus 4y equal to 13 times 4 is 52, which is like a deck of cards. All right. Bring this guy down here just so I can stack them. X plus 4y is equal to 22. And then I need to subtract. Okay, and it works like this. 16x minus x is 15x. 4y minus 4y is going to be 0. And 52 minus 22 is 30. Ah, nice and clean. X is going to be equal to 2. Take it and let's plug it into that first one. All right, we're going to put in 2 plus 4y is equal to 22. Subtract our 2 from both sides. 4y is going to be equal to 20, so y is going to be equal to 5. So critical, of course, for us to be able to do our operations well, right? All right. Our last little problem here. We have a business with 2 locations. By 7 large delivery vans and 5 small delivery vans. Location A receives five large and 2 small for a total cost of $235,000. Location B receives 2 large and 3 small oh gosh, guys, I got this all backwards. 7 large, 5 small. Location A, I'm sorry, I got these numbers wrong. Let me redo that. Location A receives, sorry, I looked at the wrong thing when I was typing this down. Receives 3 large and 2 small for a cost of, that one's $270,000. Location B receives four large and 3 small trucks for a total cost of, this one is $375,000. Cost of each type. Okay. These are variables here. We're going to let X be the cost of large and Y be the cost of the small van. So the important thing as we start these problems is that we need to define our variables. Okay. So for the first one, location A, it's going to be 3 times the smalls, or sorry, 3 times the large plus 2 times the small is going to be 270 grand. And then for location B, it's 4 times the large, right? And then 3 times the small. And that's going to be this cost, 375. All right, gentlemen, here is where it gets a little exciting. Probably helps if we have a calculator handy. Now, you're probably looking at these and thinking, how am I going to eliminate one of these variables? Okay? Because I don't want to solve for just y or just for x. So the way I'm going to eliminate these is the same way that we do improper fractions, okay? Sidebar. Think about this. When you guys add the fractions 1/6 plus 1/7, right? There's a quick way to do this to get these common denominators, right? Don't you guys just use the 2 common denominators? So you're going to multiply times 6 and times 7, right? So you're going to get 7 over 42 plus 6 over 42, right? Times 6 times 6, and this guy's times 7 and times 7, okay? Similar idea is going to be done here. I'm going to go back, and what I'm going to do is I'm going to multiply, getting rid of one of the x's or the y's. Let's actually get rid of the y's first. So here's what we're going to do. We're going to multiply a times 3 and b times 2. Once you guys see the result, you're going to see why we did that. So 3 times 3x is going to be 9x, right? 3 times 2y is going to be 6y. And 3 times 270,000, for the record, is 810,000. Okay. Now, same deal here. I'm going to multiply. 4 times x is 8x. 2 times 3y is going to be 6y. You guys see it now, I hope? Right? When we multiply, now we have our matching coefficients. Okay? And then our 2 times 375k is going to be 750,000. And then now we're going to just subtract. And I'm going to subtract this bottom one. I think you guys see why. 9x minus 8x is going to be x. 6y minus 6y is going to just cancel. And then 810 minus 750 is going to be 60,000. That is our cost of our large van. Okay, and then now we need to use that to get our small van cost. So we're going to take this x, let's put it back into this original equation here. We're going to have 3 times 60k plus 2y is going to be 270,000. So 180,000 plus 2y is going to be 270. So minus 180,000. 2y is going to be equal to 90,000. So when we divide by 2, y is going to be equal to 45,000. And this is going to be our small van cost. All right. All of that available here in Canvas. Available here on Twitch. Go ahead and put your assignment on Canvas. Good luck.